In today's video, we will do the reaction mechanism for the Diekmann condensation. So on the exam, they might ask you, give an example of what the Diekmann condensation can look like. So that just tells you that a Diekmann condensation, it's basically claisen, but it's intramolecular between two esters. So let's do an example together. So the first step of pretty much every condensation reaction is the fact that you have an acidic hydrogen and you want a type of base. We use NaOET because we have ET here. We use a base to deprotonate this. To give us an enolate. And this enolate can be written as such in a way that is more helpful for us to do the problem. Okay. And then you have the rest of our group down here. So this is our nucleophile. Our nucleophile can attack the electrophile in this molecule. In other words, we will join this alpha carbon with the carbonyl carbon, and we have 2, 4, 5. So that gives us a 5-membered ring. Also, most of these condensation reactions are in equilibrium, although it mostly favors a forward reaction, but just to be safe, you can write equilibrium arrows. So 5-carbon ring. And a quick tip is that you have alpha carbon here, and adjacent is going to be that carbonyl carbon's former location. But now it's not going to be a carbonyl because we pushed that double bond on the oxygen. And on our alpha carbon, we have a branch. Okay, now this negative charge will come down to form a carbonyl. And to respect the octet rule, then this, since it's an ester, becomes a leaving group. So that gives us a beta keto ester, but in a ring. So when you see this on the exam and they ask you what reactants you had, you first identify the fact that it is a beta keto ester. That tells you it came from 2 esters, and the fact that it's a ring tells you it came from the Diekmann's condensation. Now this looks like it's finished, but it really isn't, because there's another honorary step that we want to write. So the first step is NaOET. We always deprotonate the alpha carbon once again in claisen and Diekmann reactions where there are esters. And then we just reprotonate it again. Please remember to write this on your exam. If you don't, it's a terrible way to lose marks. So that deprotonation happened the same way as before. It's just an E2 elimination. So our negative charge here, that gets pushed up, right? So then we get like an enol. And yeah, so this is the Diekmann's reaction, same thing as claisen. You form a beta keto ester from 2 esters. And quick tip is that for this reaction, it's kind of obvious, it'll be a 5-membered ring. But if you have a 1,6 diester, meaning you have 6 carbons, this is 1, 2, 3, 4, 5, 6, like this, then you will have a 5-membered ring. Whereas if you have a 1,7 diester, you will have a 6-membered ring.